This video is to show how a function composed with its inverse, especially with trig functions, can do some interesting things. And so several examples to illustrate that. And the main point is that a function, together with its inverse, if you start putting the output of one into the other, the kinds of thing that you expect to happen, for example, when I do f inverse of f of x, is to get back what you originally put in. These functions are supposed to undo each other, and you put in x, something happens to it, but whatever happened to that x by putting it into f gets undone by f inverse, and you just get back what you put in. But that's requiring that f of x is actually one-to-one, is actually invertible. And what happens in practice is you have something like x squared, which is not invertible. It's not one-to-one. So you restrict its domain, and you say, okay, let me just look at the non-negatives to come up with this formula for the inverse, the thing that undoes it. But what happens is you've lost some information. And so this first example, the only one that's not trig, the square root of -3 squared, illustrates the kind of thing that can happen. So I've got the square root, let's see, -3 squared, that's 9. -3 times -3 is 9. Square root of 9 is 3. Not exactly what we put in. It's the opposite of what we put in. Now these other 6, I'm going to do one by one, and the first 3 I'll do on this video, and then I'll make another video. It's just going to be too long if I do all 6. But I recommend that you pause this video right now and write them all down so that you have them available and see which ones I'm working on. And if you want, it would be great just to try them yourself before I even do them. So here's the first one. The tangent of the arctan of -1. So I start with the inside and I say, okay, so the arctangent of -1 is an angle theta that has 2 properties. First property is that the tangent of theta is -1. Sort of what you mean by the inverse, tangent. Here was an input that is now an output, and here is an output that is now an input. So that's the basic idea of an inverse function. But the other property has to do with the restriction of the domain of tangent that we did to create arctan in the first place. And that restriction is that theta is between -π12 and π12. So when I look at what the arctangent of -1 is, yes, I have to see an angle that the terminal side of the angle has slope -1. But there's lots of angles that do that, depending on whether I'm here or here, whether I've gone around the circle several times or not. But the one I'm looking for is exactly this guy that's between -π12 and π12. And what is that angle? That's -π4. So now I have what the arctan of -1 is, and I can move on. So the tangent of the arctan of -1, and what is that? Well, wait a minute, we were just sitting here at -π4. The tangent of -π4, the slope of that line, -1. So here's a case where the function evaluated at its inverse actually gets out what you originally put in. Put in -1, get out -1. So nothing weird there. So let's try the next one. This one is the arctan of the tangent of -π3. So I start with the inside, and I say, okay, the tangent of -π3, tangent, let's see, -1π3, -2π3, -3π3. I'm down here for -π3. This looks like my x-coordinate is a half, my y-coordinate's the big one, and it's negative, square root of 3 over 2, and so my tangent is the y divided by the x, which is the same as times the reciprocal of that x, and so we get out negative square root of 3. Okay, so the tangent of -π3 is negative square root of 3. So what I'm looking for is the arctangent of negative square root of 3. And what that is an angle that has two properties. First property is that the tangent of that angle that we're looking for, the answer to this problem, the tangent of that theta is negative root 3, and it's the one between negative pi halves and pi halves. So I go, okay, so tangent is negative root 3, that's going to be there or there. Oh, but it's the one that's down here between negative pi halves. Oh, exactly the angle I was just playing with. Negative pi thirds is the angle whose tangent is negative square root of 3 and who lies between negative pi halves and pi halves. So far, everything's going great. Next one, arctan of tangent of 2 pi thirds. Go through my normal process. I look at the inside first, and I go, okay, great, what is the tangent of 2 pi thirds? And there's 1 pi thirds, 2 pi thirds, 3 pi thirds. So we're up here, where the x-coordinate is negative a half, and the y-coordinate is positive square root of 3 over 2. And wait a minute, that's got exactly the same slope as we were looking at before. Here the x was positive and the y was negative, but the values are the same. I'm going to get negative square root of 3 for that tangent of 2 pi thirds. So great, okay, so arctan of negative square root of 3. And so this is going to be an angle. It's going to be an angle. And it's the angle that has two properties. The tangent of theta is, and there's a negative sign in there, negative square root of 3. Wonder if I can just erase, I erased too much. Trying to make that clear that that's a negative root 3. There we go. So it's the tangent of this angle we're looking for is negative root 3, and it's the one that's between negative pi halves and pi halves. And yeah, we were just doing that a second ago. The last problem, we looked at what the arctan of negative root 3 is. It's negative pi thirds. And here is the first example with the inverse trig functions, where you don't get out exactly what you put in, similar to when I did the square root of negative 3 squared and got 3 instead of negative 3. All right, so I'm going to go ahead and start another video to do the last 3. So I hope to see you soon.